Okay, so this is test number 2 solution. So the first problem asked you to find the critical numbers and the value of the function at the critical numbers. So the function was 2x cubed plus 12x squared minus 126x plus 7. So we take the derivative. We get 6x squared plus 24x minus 126. And you see that we could factor out 6. So if you divide 24 by 6, you'll get 4. And 126 divided by 6 is 21. And then you can factor the quadratic, and you'll have x. So what numbers multiplied together give you 21? It's 3 and 7. And you can see the difference between those is 4. We need to put the positive with the bigger number so that the sum of those two becomes positive. So you get that. So the critical points are x equals -7 and x equals 3. And then you evaluate the function at -7. So that's 2 times -7 cubed plus 12 times -7 squared minus 126 times -7 plus 7. If you do that, you'll get 791. And if you evaluate the function at 3, that's 2 times 3 cubed plus 12 times 3 squared minus 126 times 3 plus 7 is equal to -209. Okay, so the second problem is we need to fill out this table and then make some comments about minimums and maximums based upon the first derivative test. So we have the derivative from the previous problem. F prime of x equals 6 times x squared plus 4x minus 21. So this is in the unfactored form. It's just a little easier to evaluate. So what we do is we have interval, and we go from -infinity to the first critical point. We go from the first critical point to the second critical point. We go from the second critical point to infinity. We pick x values of x. We evaluate the first derivative at those values of x, and we make some comment about increasing versus decreasing. So I'm going to choose -8, which is the next integer that's in this interval. 0 is in this interval, and the next number larger than 3 is 4. So what we do is we evaluate the derivative at -8, and we can do it at 0 easily, because if you plug 0 in, you'll get these two will disappear. So you have a so we know f prime of 0 is going to be negative because you have 6 times -21, so that's negative. So most likely these are positive, but we have to verify it. So you'll have 6, and really all we have to do is we have 6 out here. So if this is positive, then positive times positive is positive. So, but let's go ahead and stick it in there. So we've got -8 squared plus 4 times -8 minus 21. So the first number, -8 squared, is 64, minus 32, minus 21, which is positive 11. So you get 6 times positive 11, which is 66, which is positive. So that goes here, positive, which is what we expected. And you can do the same thing at 4. So it's 6 times 4 squared plus 4 times 4 minus 21. So 4 squared is 16 plus 4 times 4, that's just 16. You add those together, you get 32. And you subtract 21 and you get 11. So the first derivative at x equals 4 is positive. So positive means increasing, negative means decreasing, positive means increasing. Okay, so you use the results of that table to make the following statements. Since the function changes from increasing to decreasing at x equals -7, and I just draw a little picture here, increasing, decreasing, we have a local maximum. And then also, since the function changes from decreasing, here's decreasing, to increasing, from decreasing to increasing at x equals 3, that's the other critical point. Since the function changes from decreasing to increasing at x equals 3, that's decreasing to increasing, we have a local minimum. Okay, so that's what it means by use the first derivative test. So it means creating the table, looking at increasing and decreasing. If there's a change from one to the other, you have a local minimum or a maximum. If it changes from increasing to decreasing, we have a maximum. If it changes from decreasing to increasing, we have a minimum. Okay, the next one asks some questions about points of inflection. So what we have is, to talk about points of inflection, you need to look at the second derivative. So we take the first derivative, and you got to make sure that you don't lose the sign information here. So here we have the first derivative is this. So oops, didn't need to do that. So I'm going to copy this. This is right after you take the first derivative, before you factor it, and before you factor some number out, if possible. Okay. So we take the second derivative, which is the derivative of the first derivative. So you get 12x plus 24. And then you set the second derivative equal to 0. And these are possible points of inflection. So we have a possible point of inflection at x equals -2, not a point of inflection. We don't know that yet. Now you set up a table, you have one less column because we lose one. We have two critical numbers, but only one possible point of inflection. You still have the same labels, intervals, so then you go from -infinity to the possible point of inflection. And we pick an x in those intervals. We evaluate the second derivative. We want the sign, positive or negative, and then you make some comment. And the comment has to do with concave up and concave down. Okay, so what we want to do is let's pick some values of x, which in the intervals. You always try to find one with 0. This one with 0 works here. And then I pick -3. So we're going to evaluate the second derivative at -3. So that's 12 times negative 3 plus 24, which is negative 12, which is negative. Evaluate the second derivative at 0. That's going to be 24, which is positive. So negative second derivative means concave down, and positive means concave up. Okay, now once we have that, we can look at the concavity, and we see that at x equals negative 2, which is a possible point of inflection, that the concavity changes from concave down to concave up. So what we can say is, we can now say, not back here, we have a point of inflection at x equals negative 2 because the function changes from concave down to concave up. Now it just has to change concavity, so it doesn't have to be up to down or down to up, it just has to be changed. Okay, so that's the question. Do we have a point of inflection? Yes. Why? Not because the second derivative is 0, but because we have a change in concavity. Now the second derivative test, there's two ways you can do it. You could evaluate the second derivative at the two critical numbers, or you could look at where the critical numbers are relative to these intervals. So since we already have the intervals, so we could say since x equals negative 7 is in the region where the function is concave down, I'll draw a little picture here, concave down, x equals -7 is the location of a local maximum. Also, since x equals 3, I think that's what it was. What was the other? Yeah, 3 is in the region where the function is concave up. X equals 3 is the location of a local, so let's draw a concave up here, that's going to local minimum. Or another way you could do is you could evaluate f double prime of -7, and what you'd find out is it's positive, and you could evaluate f double prime of 3, and you'd find that was actually at -7, it's negative. So let's just plug it in there. What is it? It's 12x plus 24. So if you plug in -7, you'll get -70, -84 plus 24. So that's negative, which means it's concave down, which means it's maximum. And then if you evaluate the second derivative at x equals 3, you'll get 36 plus 24, which is 72, I think. No, it's not. 36 plus 24 is 60. So it's 60, so it's positive, which means concave up. Okay, so either way. Okay, so that was number 3. Number 4, you were to look for a local or absolute maximum and absolute minimum. So the function, say third order equation, so all we have to do, so for finding absolute extreme, is you're going to find if there are any critical points in the interval, which is given in the problem, from -2 to 6. And then we'll evaluate the function at the critical numbers and the endpoints. So the first step is to take the first derivative, which is going to be -9x squared plus 30x plus 7. And as it says, you will need to use the quadratic formula. So we have a is -9, b is equal to 30, c is equal to 7. And the quadratic formula says x, the zeros, are -b plus or minus the square root b squared minus 4ac over 2a. So if you plug those in, you'll have -30 plus or minus the square root of 30 squared minus 4 times -9 times 7, all divided by 2 times -9. And when you do that, you'll get 3.55 and -0.219. And then what we're going to do is we're going to evaluate the function. We'll start at the most negative number, which is the left side of the interval. We'll then evaluate it at -0.219. We'll evaluate the function at 3.55. These both are in the interval from -2 to 6, and then we evaluate 6. So if you do that, here you should have gotten 50. Here it's -20.8. This is negative. No, it's not. It's not. It's the next one. Okay, so make sure I got this right here. Okay, 6 is -86. 3.5 is 59. And what is 0.21? Let me try that one. 3 times -0.219 cubed plus 15 times -0.219 squared plus 7 times -0.219 minus 20, and to get 36.0 basically. And this is one of these cases where I'm not 100% sure I did that correctly, so I'm going to just cheat here a little bit. I'm going to plot this function. -3x cubed plus 15x squared plus 7x minus 20. So here it is. Going to zoom out a little bit. So yeah, the critical numbers here you can see -0.2 something and 3.56. So let's just check our numbers here. So f of -2, that's 50, so that matches up. F of -0.29 is about -20 something. Okay, so that's where I did it wrong. Let's look at the next one, 3.55. That's about 59, so that matches up. And f of 6 is -80 something. Yep, okay, so it's this one that's the wrong one. So let me go back to my calculator, try to figure out what the heck I did wrong. Oh, I gotta insert a negative sign, I think. That didn't help any. Okay, so let's try it again here. So we've got -3 times -0.219 cubed plus 15. I had 12 for some reason. 12 times, oh, decimal point wrong there. Boy, I'm messing all places up. -20.78, that sounds more reasonable here. -20.8, let's say. So let's go ahead and check my answer here. -20, there we go. Okay, so those all look good now. So what we can do from there is we look for the largest number, which is right here. So this is the absolute maximum, which is at a critical point. But this is the absolute minimum because it's the smallest. So those were the two values. And I said, you know, they should be x and y values. So we have negative or 3.55 comma 59. That's the absolute max, and we have 6 comma negative 86, which is the absolute minimum. And if you go to the curve, you can see here's the start here. So this one is the absolute maximum, and then the absolute minimum there. So this is the max, this is the min. Okay, the next two are the optimization problems. So I simplified this thing down from what I originally had, but we had 2 times the first number, and I'm trying to remember, I know I changed this, so I'm going to, I don't think I have anybody's, I think what I did was I had 2x plus 5y equals 50, and the product was just x times y. Hold on, let me check what I sent. Okay, this is what I ended up giving you guys. Is I had the first 2 times the first number squared plus 5 times the second number equals 50. And so this is the thing that I'm trying to either maximize or minimize. So that's the primary equation. And then the secondary equation is this one. And I'm going to solve for y because I have y and x in the primary equation. So you have 5y is equal to 50 minus 2x squared. If you divide both sides by 5, you get 10 minus 2/5 x squared. So then we substitute this, the secondary equation, into the primary equation. So you'll get x times 10 minus 2/5 x squared, which is 10x minus 2/5 x cubed. So that's the product in terms of one variable. Then to find the location of the maximum or minimum, you take the derivative of this primary variable with respect to the variable, and you get 10 minus 6/5 x squared. And then you set that equal to 0 because you want to find the values of x where you have a 0 slope. And you can solve for x. So the first thing we'll do is we'll subtract this from both sides. So we get 6/5 x squared equals 10. And if you multiply by 5/6 on both sides, you'll get just 1 on the left-hand side and 56 on the right-hand side. That's squared, so x is equal to plus or minus the square root of 50 over 6. We'll take the plus because they're positive numbers. So you take 50 divided by 6, raise it to the 0.5 power, and you'll get 2.887. And then you plug back in to the secondary equation. So the one we used here. So y equals 10 minus 2/5 y x. So y equals 10 minus 2/5 times 2.887. So 10 minus 2 divided by 5 times 2.887, and we get 8.85. Okay. Let's double check, make sure I did this right. So well, yeah, we don't know. We don't know what the product is. We could do that, but let's plot the original function here in terms of one variable. So what we're going to do is we're going to take x times 10 minus 2/5 x squared. 2 divided by 5 times x squared. Plot that, and you can see what that looks like. And so we have a maximum right here, which is at x equals 2.88, and y equals, well, this y is not the y that we're talking about here. This is actually the product. But we did find the value of x, where this thing. So as long as I did this math correctly, we're good. I guess you could go back and plug that into the first equation. So let's just do that. So the sum is 50. So what we did is 2 times the first number squared, which is 2.887, and 5 times the second number, 8.85, and that should equal 50, or close to it. 2 times 2.887 plus 5 times 8.85 is, must have put something wrong in there. Oh, I got to square that. What did that do here? I don't know what it did. Let's try this again. 2 times 2. So this is this number squared. 2 times 2.887 squared plus 5 times 8.85. Still got the wrong number. Okay, let's go back here. 2x squared plus 5y. Maybe I did get y wrong. Two x squared plus 5y. 2x squared plus 5y. Okay, so let's go back here. I know this number's right because I looked it up. And let's go back and make sure I've solved this thing correctly. Yeah, that looks right. Oh, I forgot. Yeah, I forgot to square it here, didn't I? Okay. 10 minus 2 divided by 5 times 2.887 squared. 6.6. Yeah, that's right. 6.67. That makes sense. But you can see how checking your answer is not such a bad idea. Okay, let's try again. 2 times 2.887 squared plus 5 times 6.67, 50. Okay, equals 50. I did it right now. Okay. The next problem, which was the corral problem. So let me just draw this thing out. So you've got these corrals like that, and I've got let me clone this thing. So you've got 4 of these things next to each other, like this. do this infinite cloner thing, and then I can. Okay, so I had 7 of these. And this was water, and this was water, so we didn't need any fence. It was deep, rapid water. And the dimensions are x. So you can see I have this fence here, this fence there, there, fence there, there. I also have the fence between these two, but there's only one of them. It's not like you double it and then need the fence there. So there's 8 x's, and then you have this vertical one, this vertical one, this 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 one. Now if I didn't have the river, I'd have 3 more x's. So these are the perimeters. If we add all these things together, find the perimeter is, which is given as 1,500 feet, is going to be 8x plus 9y. So 4, 8, and then you get 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the secondary equation, and that equals 1,500. So you get 1,500 equals 9x plus 8x plus 9y. And then you've got the area. So the area of these corrals is just the x times y, but we have 1, 2, 3, 4, 5, 6, 7, so 7. So that is my primary equation. That's what I'm trying to maximize, is the area. So again, you can solve either for x or y. I solve for x, and you get, let's just do it instead of me just writing it down. So what you do is you'd, let's say, solve for x. I'm going to subtract 9y from both sides, and then I'll divide by 8. So 1,500 divided by 8 is 187.5, and I'll just leave this as a fraction. No, I didn't. I left it as a decimal. So 9/8 is 1.125 y. And then you plug that into your primary equation, like that. And we want to, then you got to multiply this by y. So this is x times y. So if we multiply this whole thing out, you'll get 7 times 187.5 is 1,313 times y. And then you'll have 7 times 1.125, which is 2.875. So 7 times that is 7 point, sorry, I got 2, 7. So 7 times 1.125 is 7.875. Okay, and then you got a y times a y, so it's y squared. So I've just multiplied it out. And then you take the derivative of this with respect to y. So you'll get 1,313 minus this double, because you get the 2 from the exponent, which is 15.75y. You set that equal to 0. In this case, you don't have to, you've only got one solution. Solve for y, you'll get 83.4 feet. And then you plug that back into here. So you get 187.5 minus 83.4 times 1.125, and that gives you 93.7 feet. And I just realized this problem, how do you use the second derivative test? So what you do is we take the second derivative of p with respect to x. So we go to this equation, and the derivative of 10 is 0. And then when you take the derivative here, you get negative 12 fifths. 6 times 2 is 12, x. And because x is greater than 0, if x is positive, so if x is greater than 0, the second derivative is also going to be less than 0. And when the second derivative, when d squared p dx squared is negative, the function is concave down. So negative means like that. Therefore, a local maximum. So that's what we're looking for. And then the final two are pretty simple. So what we're looking for is the limit of these, which is ultimately the horizontal asymptote, but we want to not write y equals something. We want to just express a number. So what you do is you look at the highest order terms, and if the exponents have the same value, then you take the ratio of the leading coefficients. So this is cubed, so the answer should have been just 2/3. The limit is 2/3. For the second one, you can see that the highest order terms have different values of exponents. So this is 2, this is 1. When this number is less than that number, the limit equals 0. And then the final one is the other way around. You have x cubed in the numerator, and you have x squared in the denominator. So because this is greater than that, the limit does not exist. Okay, now there is a slant asymptote that exists, and that's what you do in problem 8. So what we do is we use long division to divide the numerator by the denominator. And I don't know how many people, I think you guys paid more attention than my pre-calculus students, but they always get this wrong and they just don't listen. So the question is, what do I need to multiply 2x squared by to get 4x cubed? So the answer is 2x. So I multiply 2x times 2x squared, that gives me 4x cubed. That's what I'm looking for. Then you have 2x times 3x, which is plus 6x squared. And then you have negative 7 times 2, which is negative 14x. Now, usually what I do is I put a negative sign out in front of this, because that's where people, they don't mess this up. It's the other terms. So whatever you need to do to remember that, do it. So that would be one way. And you'd have negative 6 minus another 6, that'd be negative 12 x squared. And then you'd have 10 minus a negative 14. Well, that's 10 plus 14, which is plus 24x. Okay. I guess another way of doing it is you could multiply this out normally and then go change the sign. So this becomes negative, this becomes negative, this becomes positive, then do it. So this plus that, you get 0. Negative 6 plus negative 6 gives you negative 12x squared, and 10 plus 14 is equal to 24. I don't like this way because I have to scratch stuff out, but that's what it takes. Okay, so what do I need to multiply 2x squared by to get negative 12x squared? So the answer is negative 6. So you have negative 6 times 2, it's negative 12x squared, and then you have negative 6 times 3, which is negative 18x. And then you have negative 6 times negative 7, which is plus 42. Okay, So if you go through and make this positive and this negative, and then you add them together, so negative 12x plus 12x, that goes to 0. You have 24 plus 38, which is 42. And really the rest of it's your material when it comes to slant asymptotes, so you could just stop there. And when I say a slant asymptote, you need to show it as an equation. Don't just put 2x minus 3. Don't just do the dividing stuff. Make sure you put it as an equation.